This demonstration will show you how to configure anti-phishing protection on the firewall. Although configuring anti-phishing protection in a URL filtering profile is a very simple task, there are some prerequisite configurations that must be completed first. To save some time during this demonstration, we will look at a firewall that has already been configured with anti-phishing protection. For anti-phishing protection to control corporate credential submission to websites, the firewall must be able to distinguish between corporate and non-corporate user credentials. This also means that you must configure the firewall with an authentication service that stores user credentials. In this demonstration, we will use an external LDAP authentication service with an LDAP user account named lab-user. We'll start by looking at the configuration by viewing the LDAP server profile. We'll view our existing LDAP server profile by browsing to Device, Server Profiles, and then clicking LDAP. Then we'll click our LDAP server profile to open and view it. The example here shows a connection to Active Directory, and it's going to a server that we've named LDAP server. This server name does not have to match the actual server name on the actual LDAP server. However, you must have the correct IP address and port number to reach the LDAP server. The remaining settings here beneath Server Settings tell the firewall how and where to connect to the LDAP server. For example, the base DN here shows the firewall where to look in the LDAP database to find the user information or group information or whatever is out there. The bind DN is the user account with the permissions to look into the LDAP database, and the password here is the password that goes with this bind DN account. The remaining settings with timeouts and all that, you can look for that information by clicking Online Help, and it will explain the timeout values to you. Since we have nothing really to change here, we're simply going to click Cancel and move on. Next, we'll see that we need an authentication profile that tells the firewall to consult LDAP for user credentials when it encounters the username, for example, the username lab-user. We'll browse to Device, Authentication Profiles, and then we'll click to open the LDAP Off Profile. The settings here on the Authentication tab tell the firewall how to interact with LDAP and get LDAP user credential information. Notice that the profile specifies the server profile that we just looked at, the LDAP server profile. It also specifies the type of external database or internal database as LDAP. The login attribute tells the firewall what attribute name to search in the LDAP database to get user account information. The user domain tells it the domain name to look in. The user modifier tells it how to modify usernames so that they match what's found in the LDAP database and so forth. Again, any of these items you can look up in the online help here up in the top corner. The Advanced tab tells the firewall for which user accounts it can consult LDAP. Notice that the lab-user is listed. This means that we can use this authentication profile to look for the credentials for a user named lab-user. Again, we have no changes to make on this screen, so we'll click Cancel to close the window. The firewall will need to be able to recognize the LDAP user account and will need to know to use LDAP to validate the user's credentials. To see how this occurs, we'll browse to Device Administrators. And then we'll click on our lab user to view the user. Notice that this user account specifies the use of the LDAP Off Profile. That tells the firewall that to verify the credentials for lab user, you must go to LDAP to do so. Notice that the administrator account also specifies whether we're assigning a dynamic or custom role to this particular account. In this example, we're assigning a custom role known as Monitor Only No CLI Admin role, and this role will give the permissions to the lab user when they log in. Again, we don't have to make any changes here because we've already configured everything, so we'll click Cancel to close the window. Anti-phishing protection also depends on certain user ID and captive portal configuration settings, so let's look at those now. First, we'll need a configured SSL TLS Service Profile. So let's browse to Device, Certificate Management, and SSL TLS Service Profile. We'll click to open the profile named Web UI Profile. This profile lists the SSL server certificate named Web UI Cert that the firewall should send to a web client to verify that the client has connected to one of the firewall's configured Layer 3 interfaces. This server certificate is required as part of captive portal operation. The firewall will send an SSL certificate named Web UI Cert to the client so the client knows it is connected to a valid server. Notice also that the web client must be able to support at least TLS version 1.1. Notice we have different choices here, but the minimum best practice is considered TLS 1.1. Again, we have no changes to make in this window, so we'll click Cancel to close it. Now we must configure the firewall to use our SSL TLS Service Profile. We'll browse to Device, Setup, Management, and then we'll click the General Settings gear icon. Notice that the firewall is configured to globally use the Web UI profile as its SSL TLS Service Profile. Globally means that the firewall will use this certificate for captive portal, VPN, Global Protect, and other firewall service connections. Again, we have no changes to make, so we'll just click Cancel. One of the reasons that the firewall must send a certificate to a web client to prove the firewall's identity is because the firewall will send a captive portal response web page to the web client as part of captive portal operation. The captive portal response web page will be used to collect the user's first factor credentials, which commonly are the user's username and password. However, before the firewall can send a captive portal response web page, we must grant permissions to the firewall to send the response page from one of the firewall's Layer 3 interfaces. This is the configuration we will look at next. To permit response pages, we need to configure an interface management profile. We'll browse to Network, Network Profiles, Interface Management, and then click to open our profile named Response Pages Ping. Notice that this profile permits the firewall to respond to ping requests, and notice also that this profile allows the firewall to send response pages as part of things like captive portal or application block pages or URL block pages and so forth. Again, we have no changes to make in this profile, so we'll click Cancel to continue on. Our interface management profile must be assigned to the firewall Layer 3 interface that will be used by captive portal to send response pages. To accomplish this, we need to browse to Network, Interfaces, and in our example, we'll click on Ethernet 1.2 to open it up and view the configuration. Here's Ethernet 1.2, and notice if we click the IPv4 tab that the IP address assigned to Ethernet 1.2 is 192.168.1.1. We'll be using this particular IP address as part of our captive portal configuration a little later on. But if we also click the Advanced tab, we'll see that the response pages ping management profile has been assigned to Ethernet 1.2. This allows Ethernet 1.2 or IP address 192.168.1.1 to send response pages, captive portal response pages, to gather first factor credential information. Again, we have no changes to make, so we'll click cancel. We also need to enable user ID operation on our internal zones. To enable user ID on a zone, we'll browse to Network, Zones, and in our demonstration, we'll click on the Inside Zone, and we'll note that user ID has been enabled up here in the right-hand corner. This is all the configuration we need on the zone, so we'll click Cancel to close the window. To continue viewing our prerequisite user ID / captive portal configurations, let's browse to Device, User Identification, and then click Captive Portal Settings tab. From here, we'll click the Captive Portal gear icon to open the Captive Portal Settings window. First of all, notice that Captive Portal has been enabled, and it has been enabled in redirect mode. Redirect mode is the only mode supported by multi-factor authentication. If you select redirect mode, then the response page that Captive Portal sends appears to come from the firewall. So we need to tell Captive Portal which layer 3 interface on the firewall to use to send the response pages. Notice that the redirect host down here has been assigned the address 192.168.1.1, which is the same IP address that we assigned to our Ethernet 1.2 interface earlier in the demonstration. Now, once Captive Portal sends a response page from this IP address to the web client, that web page is going to gather the user's first factor authentication credentials. That will typically be the user's username and password. Once that username and password has been received by the firewall, then notice the authentication profile says to use LDAP Off Profile. In other words, go to LDAP to verify that user's credentials. We did not specify an SSL TLS Service Profile here because we assigned one globally back at Device, Setup, Management, and so forth. We saw that earlier in our demo. Once again, all these remaining timeout values and port numbers and whether or not to enable roaming, these all can be learned by clicking on the online help and viewing the information there. We have no changes to make here, so we're just going to click Cancel to close the window. While we are still in the user identification area, we're going to go ahead and click the Group Mapping Settings tab, and then we're going to click to open our LDAP Group Mapping Profile or configuration. This configuration tells the firewall how to read user group information in LDAP. The firewall needs to know this information because for the anti-phishing protection on the firewall to be able to block credential submissions to websites, it must be able to determine what are or are not corporate credentials. Being able to read username, password, and group information in LDAP enables the firewall to determine what corporate user credentials are. Notice on the Server Profile tab here, we've specified that the firewall should go out to LDAP to get the user group information. And as far as group objects, we should search LDAP here to get group information. To get user objects, we should search LDAP here to get this information. And of course, it's all enabled. Now, while we're here, we also want to click the Group Include List tab. And over here, this is where the firewall would show us all of the groups built into the LDAP system. Now we've added a particular group over here, lab users, and the users in this group are the users that we're interested in from the firewall's perspective, from the perspective of captive portal. Our lab-user user is a member of the lab users group. And so we want the firewall to use the included groups here to go ahead and retrieve group information associated with our lab-user username. Once again, we have no other configuration changes to make here, so we'll click Cancel. Now let's go ahead and click the User Mapping tab. User ID must monitor devices for login and logout events so that it can map IP addresses to usernames. User ID can monitor events from a variety of sources, including Windows hosts, terminal servers, and network access points. To monitor these devices, User ID includes a firewall-integrated User ID agent and a Windows-based User ID agent. The demonstration here is limited to configuring the firewall-integrated User ID agent to support anti-phishing protection. Let's click the Palo Alto Networks User ID Agent Setup right here, gear icon. This allows us to view the configuration of the firewall integrated User ID agent. To perform IP address to username mapping, the agent must be able to query login and logout events in the Windows environment. In the username and password fields, we see the username and password of the LDAP user that has permissions to view Windows logs for login and logout events. This is the only setting we are required to modify, so we'll just click Cancel to close this window. While we are still here on the user identification screen, let's scroll down to the Server Monitoring tab here, or the Server Monitoring pane, and we'll click to open our LDAP server configuration. User ID must know which Windows server to monitor for login and logout events. This would commonly be an Active Directory domain controller server. The name here of LDAP server does not have to match the actual host name of the server. What does have to match is the IP address down here. This must be the IP address in this example of one of our Active Directory domain controllers. Notice that we have enabled server monitoring. We are enabling Active Directory. Other things are available for monitoring, other types of domains. And we are going to use Windows Management Instrumentation to do the monitoring of our Windows Active Directory. While WMI is not the most secure of the methods available, it is the simplest to set up. If you choose to use one of these HTTP methods, additional configuration settings are going to be required. We don't have to change anything else on this window, so again, we'll click Cancel to close the window. What initially invokes Captive Portal to send a response page to collect a user's first factor credentials is a network traffic match to an authentication policy rule. So we must also configure the authentication policy. But before we view the policy, we have to view our configured authentication enforcement object. Let's browse to Objects and Authentication, and then click to open our CP Web Form method authentication enforcement object. When there is a match to an authentication policy rule, the rule will invoke an authentication enforcement object. In our example, it's going to invoke this authentication enforcement object called CP Web Form method. This particular object says that we want the firewall to use Captive Portal to send a response page to the user. The response page will use the web form method to collect the user's first factor credentials. The web form method will interactively ask the user to provide their username and password. These credentials will be validated against LDAP because the configured authentication profile, shown right here, is our LDAP Off Profile. So web form collects the username and password, and it's compared against LDAP because of the LDAP Off Profile. There's nothing to change here. Let's go ahead and close this window by clicking Cancel. Now let's look at the authentication policy rule that would invoke the authentication enforcement object that we just looked at. We'll browse to Policies, Authentication, and then we'll look at our Invoke Captive Portal rule here. This rule would match traffic from any user, from any IP address going to any IP address, as long as it was sourced from the inside zone, was going to the outside zone using some method of HTTP, and if the traffic matches these conditions in here, then we're going to invoke the CP web form method authentication enforcement object, which essentially says send the user a response page, which is a web form requesting them to enter their username and password. Of course, the firewall will then compare that against LDAP to determine information about that user. There's nothing really to change here, so there's really nothing to do. Now, our viewing of the prerequisite setup is complete. Now we can view the configuration of URL filtering to provide anti-phishing protection. First, we'll browse to Objects, Security Profiles, URL Filtering, and then we'll click our Outbound UF profile to view its configuration. In the User Credential Submission column, notice that everything has been set to block. That means if we try to submit our corporate credentials to one of the websites in one of these categories, the firewall is going to block that credential submission. You should assign either an action of block or continue to any untrusted website. If you configure block, then you are blocked. The firewall blocks you from submitting your corporate credentials. If you configure continue, then you still get a response page, but you're given a response page with a warning telling you of the potential danger. We've just configured block for all of our websites and categories. In addition to configuring the action to take if a user tries to submit credentials to a website, we also need to configure the User Credential Detection tab. Currently, we have configured the User Credential Detection method to be Use IP User Mapping. Notice there are two other methods available, Use Domain Credential Filter and Use Group Mapping. These three methods use different ways to map usernames to IP addresses to detect corporate credentials so that we can decide whether or not to block them. They all use different methods to accomplish this. Some methods are stronger than others. Some methods take more setup than others. We've used the Use IP User Mapping method. The Use IP User Mapping method enables user ID to detect valid corporate usernames. This method does not check passwords. User ID determines a username match by matching the detected username against the user ID IP address to username mapping table. User ID also verifies that the username matches a current session. This method can result in some false positives because it only identifies submission of a username coming from the IP address associated with the same username. The Use Group Mapping method, which is one of our alternative methods right here, the Use Group Mapping method determines if the username matches any valid corporate username. Again, it does not check passwords. The firewall matches the detected username to the list of usernames in its LDAP user to group mapping table. This method could produce more false positives than the other methods because it identifies any username defined in the domain, even if the user submitting the credentials is not the same person. We configured our firewall to support this method, but we are not using it. The final method, the use domain credential filter method, enables the firewall to check for an exact match to a valid corporate username and password. User ID uses Bloom filters to determine if the username and password detected in the user's web traffic matches the user's corporate username and password. The password or hashed password is never sent to or stored on the firewall. This method produces the fewest false positives but requires more initial user ID configuration than the other two methods. For example, it requires you to install and configure a Windows-based user ID agent on a read-only domain controller in your Active Directory domain. It also requires that login and logout information be available in the Windows event logs. Anyway, we have no changes to make here either because it's already been configured, so let's just click Cancel to close the window. Now let's open a browser tab and test our configuration. So we're going to open a browser tab and we're going to browse to https www.icar.org. Because this traffic matches our authentication policy rule, Captive Portal was invoked and sent a response page to collect the user's first factor credentials. We'll type in lab-user, which is in our LDAP database, and the password Palo Alto. And now the firewall has our user ID information and presents us with the website. Now let's try to submit our corporate credentials to this website. Let's click the Download Anti-Malware Test File page, and notice over here we're prompted for a login and password on this website. So we're going to go ahead and type in our corporate username and our corporate password and try to log in. And then notice that we are immediately given another response page, this time a block response page, telling us that according to company policy, we cannot submit our corporate credentials to this website. This concludes our demonstration of the anti-phishing protection configuration.